These are the 4 problems from page 307 that I said we would work together. So we're going to start off with number 15. Number 15 says that Tara exercises 75 minutes a day. So I'm going to go ahead and write that down. I know she is exercising 75 minutes. She does cardio, which burns an average of 10 calories per minute. So I'm going to write that down just as we go. Cardio is 10 calories per minute. And weight training, so weights, burns an average of 7.5 calories per minute. Write a polynomial to represent the amount of calories Tara burns in one day if she does X minutes of weight training. So we know she's going to do X minutes of weights. Now here's the deal. We know that she has a total of 75. So let's say if she did 5 minutes of weights, that means she would do 70 minutes of cardio. So to get our cardio, it's going to be 75 minus whatever time she does for weights. Okay. So now we know that it's going to be 10 calories for this amount of time and 7.5 calories for this amount of time. All right, because this is minutes. And then all together, okay, all together is what they're wanting to know. The total, write a polynomial to represent the amount of calories she burns in one day. So we're going to say, okay, she has 10 calories for this amount of minutes. For every minute this represents, plus 7.5 calories times X amount of minutes. All right, so it's this times this amount, this times this amount. So now we're just going to simplify. Distribute my 10, and I get 750 minus 10x plus 7.5x. I need to combine my like terms. My like terms are my x's. So it's 75 minus 2.5x. And that's my answer. I blacked this out because that was showing the answer and I wanted to work it first. So there we go. Okay, what was the next one? Number 40. Okay, number 40 is kind of the same type of problem. Connor has hired 2 painters to paint his house. Okay, the first painter charges $12 for every hour. Okay, $12 every hour. The second painter charges $11 every hour. Okay, and it's going to take a total of 15 hours of labor to paint the house. So part A says, write a polynomial to represent the total cost of the job. Okay, so part A says, write a polynomial to represent the total cost of the job if the first painter does X hours of labor. So he's going to do X amount of hours. And we know that we have a total of 15 hours. So if he does an X amount of hours, we know the second guy is going to do 15 minus X hours. And that makes sense. If he's going to do 5 hours, then that means the second guy is going to do 10. And we get that by subtracting what this guy does. Okay, so now write a polynomial to represent the total cost. So I know my first part is going to be $12 times X amount of hours plus $11 times his amount of hours, which is 15 minus X. So now we're going to simplify this. I have 12X plus, distribute the 11. 11 times 15 is 165, minus 11 times X is 11X. Combining our like terms, 12X minus 11X is 1X, or just X, plus 165. So that's our answer for part A. Part B says, okay, write a polynomial to represent the total cost of the job if the second painter does Y hours of labor. Okay, so I don't have this part anymore. They're changing it. Okay, so our second painter does Y amount of hours. So if he does Y and we still have 15 hours total, this guy does 15 minus Y. Okay, so let's do our first painter. It's $12 for every hour. His hours are 15 minus Y. Plus our second painter, which charges $11 times his amount of hours, which is Y. Okay, distribute. So 12 times 15 is 180. 12 times negative Y is minus 12Y plus 11Y. 180 minus Y. And that's our answer for part B. Number 46. Okay, number 46, I'm going to, this 2 has to go with everything inside this first set of parentheses. So I'm going to say, okay, I have negative 3 squared, and I have x to the third raised to a power, so we multiply the exponents, so that's going to be x to the 6th. Then I have y squared, which is just y squared, and that's in parentheses, times 4xy squared. Now this 2 didn't go with everything because it's on the inside of parentheses, not the outside. So I'm going to kind of fix this. This is actually 9. So that's 9x to the 6th y squared times 4xy squared. Now we're going to multiply. 9 times 4 is 36. X to the 6th times x to the 1st is x to the 7th. Y squared times y squared is y to the 4th. And that's my answer. And last one, number 61. Okay, number 61, the polynomials, and they give me this long polynomial. I'm just going to kind of highlight it. I don't know why it's not letting me do that. So here's my first polynomial. And then here's my second polynomial. Okay, so instead of me writing those down, I'm just going to highlight them. Okay, so the polynomials, here's my first one, here's my second one, approximate the number of bachelor's degrees in thousands earned by males and females respectively, where X is the number of years after 1971. So when it says earned by males and females respectively, that means whichever one they named first, which was males, this is the one that goes with males. This is the polynomial that goes with females. So part A says, find the polynomial that represents the total number of bachelor's degrees in thousands earned by both men and women. So if they just want to know the total amount, doesn't it make sense that I would just add those two together? So 0.108x squared minus 0.876x plus 474.1 plus 0.047x squared plus 9.694x plus 361.7. So now we're just going to combine like terms. This x squared and this x squared can go together. Okay, when I add 0.108 and 0.047 together, I'm going to get 0.155x squared. Now I have this that I can combine with this term. When I add those together, I'm going to get plus 8.818x. And then when I add 474.1 and 361.7 together, I'm going to get 835.8. And that is my answer for part A. Okay, which is also what they put here. Okay, so part B says, find the polynomial that represents the difference between bachelor's degrees earned by women and women. So this time I'm just going to subtract the two. So it's the exact same problem. So I'm going to write this first polynomial down. But this time I'm subtracting this entire polynomial. So when you add or subtract these numbers, you have to make sure that you distribute that negative sign out in front. So it's going to be minus 0.047x squared minus 9.694x minus 361.7. And when you add your like terms together, you're going to get that as your answer. So 0.061x squared minus 10.57x plus 112.4. Okay, that should finish up page 307. If you have any questions, you can let me know in class.